that recording? Okay, this is recording. Hi to everyone if you're watching this at home. This main purpose of recording these lessons is to make sure you stay up to date, make sure you're revising, and if there's anything you've missed that you want to go over, to watch me. It's better to have the notes in front of you at this stage. I haven't quite figured out how to get the slides into the actual videos. That'll come. And what I might do is I'll get him to move this way and stop there. Cool. Much better. That'll be my thing. So I'll go to YouTube channel, link up on Daymap for you to see. Now, topic 1, we are going to be looking at the atoms and the periodic table. All right, how many of you have seen that before? Good. Should be all of you. All right, you can't come to this without seeing it. The periodic table looks like this. It's a series of letters arranged in a certain fashion. And we're going to explore why they're arranged in that fashion, because that actually tells you how those atoms and those elements behave with each other. So firstly, a bit of Year 10 revision. There are 3 different types of reactions in the universe. Okay, the first is the chemical reaction, which is what we're going to be focusing more on. New substances are formed and the reactions are not easily reversed. The atoms rearrange their bonds. Signs that a chemical reaction has occurred include the following, but we'll see how much we know. So just get that down, and then I'm going to ask you, what are the signs of a chemical reaction occurring? Okay, what was your name again? Philippa. What was yours? Gas being produced. Correct. That's a good sign that a reaction has occurred. We have a special name for it. It's called evanescence or effervescence. Effervescence. That's the word. I'll put it up later. That's usually evidenced by bubbles. Okay? If you're producing gas, particularly if you've got 2 liquids, bubbles will come off. That's a sign of a chemical reaction. What's another sign of chemical reaction? Yep. Joel? Color change, correct. If I burnt this table, i.e. reacted it with oxygen, it would go completely black. Okay, because I've changed the color, chemical reaction has occurred. Yeah, Coop? Precipitates formed. What does he mean by precipitates, Riley? Correct, a solid is formed in that reaction. Awesome. Good. Change in temperature, that's it. Good. So heat is the main one. Can be either, a heat change, I guess, is what we really want to be looking at. Exothermic, which produce heat, or endothermic, in which the reactions get cooler, or the surroundings get cooler. Gases produced, okay, bubbles, fizzing. Smells, if you smell a change, that means a gas has been produced, because that's what smell is. It's based on detecting air particles. Permanent color changes are a sign that a reaction has completed. Permanent color changes. And precipitates, as Coop and Riley said, that's when a solid substance forms from 2 liquids, or a gas in the liquid, okay? It's basically when you form a solid from 2 things that weren't solids before. So that's the Year 10 sort of stuff. And I'll let you get that down, but the next part, you don't necessarily have to take notes for. And again, all the notes I put up here will be in Word doc form on Daymap. Okay, there is no excuse for not revising. All right, let's move on. Okay, probably don't need to write this down, but physical reactions are the other type of reactions that you might see. And this is the simple, basic year 8 stuff of solids into liquids, liquids into gases. Okay? You don't form a new substance, and the reactions are very easily reversed based on changing the temperature or the pressure. So they're often changes of state. You could have hydration, dehydration, or when you dissolve a solute, it's actually a physical change. When you get a bunch of salt and put it in water, you don't actually create a new chemical, you just have salt spread in the water column. So if you condense gas, you can create a solid or a liquid. If you evaporate liquids, you can get a gas. If you melt a solid, you'll get a liquid. Those sorts of things. And the fancy one, which is when you go straight from solid to gas, is called subliming. And I'll show you what that is later on. I've got some iodine, and I'll show you what I mean by sublimation. That's just when the solid just converts straight to gas. Okay? So again, I don't expect you to write that down. That's year 8, year 9 science. And I don't expect you to write this down because we're not going to be dealing with this in chemistry this semester. But it's just to make you aware of the third type of reaction in the universe, nuclear reactions, which involve rearranging the particles in the nucleus of an atom. That's when you split an atom. Okay? Where do we use that? Anyone know? Chris?
Nuclear fission.
Nuclear fission, which is?
Power plants.
Power plants. And sometimes dropped on persistent enemies as a nuclear weapon. Okay? So you'll get your nuclear fission, which is fission just means breakdown, which release a lot of energy. And the other kind is fusion, which occurs in the sun. All right? So fusion is when two particles in the sun collide and create a new atom. We also have a hydrogen bomb, which is a fusion-based nuclear weapon, which will do the fission first and use that heat to collide the particles to create even more heat. So they drop one of these, they tend to be, 1,000 times more powerful than the ones dropped on Hiroshima and Nagasaki. Okay? Just to be a friendly thing to be aware of. Also, Donald Trump has the codes for these now, so that's nice. Fantastic. Looking forward to that. I'll skip that. Okay. A chemist's language. We're going to use several different words within chemistry, and I want you guys to be really aware of them, because when they crop up, you might think, what are they talking about? First thing that I deal with is the atom. That's the basic. It's the first Lego brick, all right? The smallest part of an element, and they are the building blocks of chem. Yeah. I'd leave that up to you. I don't want to be bogged down in people not writing as fast. And again, if you get your laptops out, these will be on day map later on. So, an atom is the smallest part of an element. An element is a substance that contains only one kind of atom. So you might have a big chunk of gold. It will only contain gold atoms. It will be elemental gold. All of these elements, all of these types of atoms are listed on our periodic table. Okay? We only know at this stage 106, and we're still synthesizing new ones as we go. Yeah. But we synthesize using nuclear reactions by basically adding protons or neutrons to the nuclei by bombarding. Yeah, in the Hadron Collider, or any particle accelerator will do it, or even a nuclear reactor. But a lot of these are so unstable that they'll break down as soon as they're created. So some only last 10 minutes or so, and some only last 2 seconds. All right? So elements are when you've got all the same kinds of atoms. Now a molecule is a bit different, because that contains two or more atoms that have been joined together chemically. They are bonded together. All right? They're sharing electrons and they form bonds. So, for example, oxygen and H2O are molecules. They exist as molecules. A bunch of atoms holding on to each other. And they're individual particles. And you might think that water is a solid. That's held together with a different kind of interaction, which we'll go into later. But, what's that?
So this will be under the class feed of...
Yes. Yep. I'll put these all under the class feed under resources. And then hopefully a link to this. I mean, this is sort of like the setting up boring stuff. What you really want to be looking at is the video for when I actually go through some problems, which I'll do that as well at some point. So you got your molecule, and overall, that molecule is neutral charged because all the charges are balanced. An ion is a different matter. Ions have a charge on them, and this could be an atom or a molecule, doesn't matter. As long as it's got a charge, it's considered an ion. And those ions will bond to each other and form an electric bond. For example, sodium ions and chlorine ions will form an electrical ion bond to form sodium chloride. Okay? So they're not actually holding on to each other, they're just attracted electrically based on their charges, because positive attracts negative. Okay? It's just like attracts the opposite. Or opposites attract would be the easier and more simple way of putting it. Sulfate is a molecule with a charge. Okay? It's a polyatomic ion. Many atoms. Other pieces of language you should know: compounds. It's when you have two or more different elements chemically combined, H2O, CO2, and a compound has different properties from the elements it contains. Mixtures. Mixtures they're not what we call pure substances. Okay, like cordial. You've got the sugar, you've got the flavoring, but it's just a bunch of different chemicals bouncing around. They're not actually bonded to each other. So a mixture are not pure substances like elements and compounds. They're simply two or more elements or compounds mixed together, but not chemically combined. Okay, they're free to do their own thing. We use mixtures in cooking because it means they can independently trigger our receptors on our tongue where we get the different kinds of tastes. If they were chemically combined, they'd only have one taste. All right? It makes for boring food. So compounds. What's the difference between? Well, molecules are a form of compound. Okay? You can have compounds that are molecules, or you can have compounds that are salts or different metal alloys. Okay? So a molecule you'll have, say, for example, with water, you've got oxygen and two hydrogens. That's compound because you've got two different kinds of atoms there, but it's also existing as an individual particle. Okay? Sorry? So you could have a carbon dioxide molecule, which is a compound. It's just, yes. We're going to do an experiment later on in which we're going to divide these up anyway. Okay? But I will definitely tell you when something is pure and something is not. So if we divide these up, just to be clear, substances can be divided into pure substances and impure substances. Pure substances could be elements or compounds. Impure substances are your mixtures. That's when you don't have the straight one thing. You've got a whole bunch of different chemicals. Elements can break down into atoms. Those atoms will make a compound as well. and elements can end up making molecules as do compounds. Okay? So oxygen, for example, is two atoms of the same element or the same type joined together to make an oxygen molecule. So a molecule is just an individual particle that is chemically bonded to another atom. All right? So that's generally how we break it down. I'm going to stop the record there so we can reflect on this, and so you're probably bored of me speaking.